Not that math isn't always fun, but calculus is particularly fun. Okay, I remember exactly where we left off.
Okay,
And
good.
So I'm going to just refresh you a little bit and put up some limit questions.
All right.
See how much we need to review. Hold on a second. Just a second. What's going on here? Let's see if this works out. Yeah, all right. So, what is the limit of
So x approaches infinity. So that's going to be the limit. So we're trying to see if I remember this right.
Think of it as the numerator and the denominator. And the numerator is growing without bound.
That's right.
So what's that equal to?
Is that infinity again?
Yes, not undefined, but infinity.
If it were on the bottom, it would be 0, right? If it were flipped.
That's what's coming up next.
Okay, so that is undefined.
Correct, because this one is different from the right as opposed to the left. If I'm approaching 0 from the right, it's positive infinity. But if I'm approaching it from the left, it's negative infinity.
Yes.
And the definition for whether a limit exists, the very first thing that has to be satisfied is the limit from the left has to be the same as the limit from the right.
Yes.
If they are not exactly the same, then it's undefined.
Yes.
Okay.
So that's going to be, is this one going to function differently because it's always going to be the same ratio?
Factor out that x. Get rid of that x.
Okay.
What's x divided by x?
That's 1.
Okay, so what's this limit?
Oh, 1/3. 1/3? Okay.
Okay. This is an interesting one.
All right. That's still 1/3, right?
Yes, it is. It's the ratio. In other words, that's a horizontal asymptote. That's where the horizontal asymptote is. And it's the ratio of the coefficients if the variable is the same degree.
All right.
Okay. These are all just kind of jumping into my head.
All right, so that'll be infinity, right?
Yep. Okay, how about this one?
Okay.
This is the first technique of solving limits. There's three techniques. This is the first one.
Is this 0? Yeah, 0.
Factor the top. The first technique is factoring.
All right, so x plus 1 times x minus 1. Oh, wait a minute. That's 2, not 0.
All right. And all factorings kind of are like this. In other words, whenever you get 0 over 0, upon substitution, the first technique to look for is, can you factor something and cancel it? And this can take many forms. Sometimes it's the numerator that's factored, sometimes it's the denominator.
Yes.
But whatever it is, you're usually going to be able to cancel out one of those factors with the other side of the fraction bar.
Okay.
Okay. Second technique.
All right.
Now you should know that all limit problems that are difficult, upon first substitution, you get 0 over 0. That's just the way things are. Anything that is not 0 over 0 is extremely easy, as my first two problems on the upper left suggest. It's either 0, infinity, undefined. Those are easy. The ones that are hard are 0 over 0.
Okay. So with this, would you just
Second technique. Remember it in terms of the number of techniques you have.
All right. So the first technique.
The second technique is, you need to remember what it is. It's multiplying by the conjugate, top and bottom.
All right. Multiply by the conjugate.
So what am I going to multiply that by? Which one? The top or the bottom?
The top.
Well,
you're going to
do both, but I get my conjugate from the top.
Yes.
So hold on a second. So I've got x plus 5 minus square root of 5 all over x. What am I going to? Can only multiply it by the number 1 without changing its value.
That's right. So that's going to be the square root of x plus 5 plus the square root of 5.
And then the bottom, go ahead.
The bottom is the same.
By the bottom by that. The one mistake you don't want to make is to go ahead and distribute that bottom. Whoops, hold on.
Okay, yeah.
And because it's self-defeating, it takes you in the wrong direction. In other words, all of these limit problems are going to be where stuff cancels. And if you want to cancel stuff, then you don't want to distribute it.
Yes, sir.
Okay? So what do I get when I do this multiplication?
All right, so you get, with the top, you just get x, because you get x plus 5.
Now let's write it out so we don't get confused. That's the first term. You know the middle two terms disappear because you're multiplying by the conjugate. So the only term we need to worry about is the last term.
That's right.
Which is?
And that is minus 5.
Okay. Now I'm going to write this exactly like this. I don't even ever want to multiply those out or distribute it. Because notice what happens?
Yes, they cancel out, and the
x always cancels out. So you end up, in other words, you know stuff's going to cancel. You just do, because of the way this technique is designed. So now we're taking the limit as x goes to, what was it, 0? Yeah.
Yes.
What's that?
So that's just going to be 1 over 2 root 5, right?
Yeah. If it's a multiple choice test, you're not going to probably see that answer on the test.
Would you see it just as
you would rationalize? You got to rationalize.
Root 5 over 10.
Well, I don't know. Let's see, I'm going to do this. Yeah, root 5 over 10. Okay, so that's technique number 2. Okay?
All right.
Where you are multiplying top and bottom by the conjugate of it, whichever one has all the radical signs.
Yes.
In this case, it was the top that had the radical signs, so I'm multiplying by the conjugate of the top. I know I have to do top and bottom because I can only multiply by the number 1.
Yes.
Okay.
That's right.
All right. Let's talk about technique number 3. Involves trig.
Right.
Trig is huge in calculus.
Oh, okay.
All right. So they have a problem when teaching calculus.
All right.
Which is they don't have to teach this to people.
Okay.
Because if you do this the regular way, it's too hard at this level of calculus. And if you do it the easy way, you don't get that for 8 chapters. So they ask you to memorize that. You happen to know what that is? It's 1.
1.
Hmm?
Okay.
Okay. And just memorize that. There's only one other you have to memorize. And it's this one. Again, notice that direct substitution produces 0 over 0.
That's right.
That one is 0.
All right.
Okay.
So the limit of the sine of x over x as x approaches 0 is 1. And the limit of 1 minus the cosine of x over x as x approaches 0 is 0.
Yeah. Now, let's say you forgot what that was. So graph it. Go in your graphing calculator and make your function sine of x over x. This is what your graph's going to look like.
Let me set that in parentheses. Sine of x.
Make sure you're in radians, always. With calculus, calculus degrees do not work. Everything has to be in radians. In other words, this limit is only equal to 1 if you're in radians, not if you're in degrees. In other words, the x they're talking about is in radians.
All right.
So you can see from the graph that it indeed approaches 1 as x goes to 0.
All right.
Okay, so that's merely confirmation. That's not quite proof. We'll get into that maybe later. You're smart enough that you can probably understand this proof. And just memorize that also. And this actually works both ways, whether it's cosine x minus 1 or 1 minus x. Cosine of x doesn't matter in the numerator.
Okay.
Okay. So let's do some trig problems.
Yes, sir.
And this is the third technique, trig. And it's all based on those 2 things I just said memorize.
This one is?
All of them.
All of them are. Okay.
Pretty much all of them. I mean, we'll get into hard, they don't give you hard ones when they're talking about limits. You'll get hard ones once you get into calculus. But in terms of limits, you solve all of these, excuse me, I didn't write this correct. I apologize.
That's what I was wondering.
Uh-huh.
Okay,
yeah,
there we go.
You write all of these trig functions, and you solve their limit based on those 2 things that I asked you to memorize.
Okay. So you would have sine of x over 5x. So is that going to be, is this 1/5?
Yeah. In other words, let's start by doing this. Same thing, right?
That's right.
Well, we know that's a 1.
Yes.
So you can multiply that 1 times 1/5, you get 1/5.
Yes, okay. That's right.
Get a little bit tougher. Yeah, why not? I'm just going to go for it here. With these trig functions, I'll give you more than just 1 or 2.
Okay.
Just because we haven't really talked about trig limits before. First, try to factor out something so that you're left with a sine x over x, because you know what that limit is.
All right, so you would have sine squared of x is just sine of x times sine of x. So you have the sine of x times the sine of x over x, which is 1. So the limit is the sine of x. Okay, is that acceptable as an answer, or can you not have x in the answer?
We know that x is going to 0, so it isn't.
All right. So
what's the sine of 0?
Oh, the sine of 0. That is 1. Is that right?
0.
Did I remember that correctly? 0.
0. It's the cosine of 0 that's 1.
Cosine is 1. Because on the coordinate plane,
it goes. About it is to think about this.
That's right. On the coordinate plane.
That's a problem, as if cosine of 0 is 1. So remembering this solidifies in your mind that sine of 0 is 0, cosine of 0 is 1.
Yes.
All right. So that goes to sine, and 0 times 1 is 0.
Yes.
All right. So 1. Yeah, let's do this one. What's x going to go to?
Is this 0 again? X goes to 0 again?
Well, the way to figure it out is to know that you got to end up with a numerator that's 0 and a denominator that's 0. That's the only way you're getting these problems anymore.
Is that only with trig, or?
No, pretty much all limit problems are going to start out. They don't end up this way, but they always start out upon direct substitution as being 0 over 0.
Okay.
Just like, in other words, you could have figured that out that x was going to 0 because that makes the numerator 0 and it makes the denominator 0.
Okay. What then where does x going to infinity come in? Where does that come in?
We'll get there.
Okay, so that's just
another number that x can go to. It can go to 0, it can go to infinity, or it can go to a number.
All right. But we're just trying to, by trying to find the numerator and denominator as 0, what are you trying to do? When you said...
First step is direct substitution. What do you get?
All right. So you get... If you plug in 0?
That's what I mean by direct substitution.
Oh, okay. Yes, you get 0.
You get 0 over 0. You don't get 0. 0 over 0 is not 0.
That's right.
It's indeterminable, is what they call it. There's a few things that are indeterminable. This comes in Chapter 8 also, but I might as well review it now. That's indeterminable.
Okay, infinity over infinity.
That's indeterminate.
Infinity minus infinity. Okay.
That's indeterminate.
So those are indeterminable.
There's one last one that I almost avoid giving you, but that's indeterminable also.
0 degrees?
Zero? No, 0 to the 0th power.
Oh, 0 to the 0.
That's equal to 1, and I wish I could tell you why it's indeterminable, because it always ends up equaling 1 when I do it. But it's classified as an indeterminable.
All right.
Okay. So what do we want to do with this? Remember, all trig questions are based on one of those first two rules.
That's right. So we're going to try to find 1 minus the cosine of x over x. Is that right?
Yeah.
All right. So get the cosine of x minus 1 over 2x squared.
I might have actually been wrong when I told you that the other way was also. No, I wasn't wrong. I was correct. In other words, your two rules are 1 minus cosine x over x or cosine x minus 1 over x. They both go to 0. Okay?
Yes, sir.
So change this thing that's circled into a cosine x minus 1 over x.
Okay, so you have cosine of x minus 1 over x times 1 over 2x.
Now we know what that goes to.
That goes to 1.
No, that goes to 0.
Oh, 0. 0. That goes to 0.
Remember, the sine one goes to 1, the cosine one goes to 0.
Yes.
What's this go to?
That will go to 1 over 2.
No?
Oh, wait. Since there's only one x, it'll go to 0.
It'll go to infinity. Remember, if the denominator goes to 0, this whole thing blows up. It's actually undefined, the way I've written it. Doesn't even go to infinity. Because if you go to 0 from the right, it goes to positive infinity. If you go to 0 from the left, it goes to negative infinity. So I actually have to write does not exist. And now I have an indeterminable. I got a 0 times a dne.
So it's indeterminable.
Well, I don't know, to be honest with you. I just picked this out of the book and realized when I tried to do it that it got this strange answer that I just came up with. Let's set it aside. I'm not interested in doing strange answer problems yet. We can always come back to those. Here, let me find one that isn't a strange one. Because this gives you an indeterminable one, which, I don't know. That's indeterminable. When you have either infinity times 0 or 0 times a does not exist, which could be a negative infinity or a positive infinity, I got to think that's 0, but I don't know for sure. It's indeterminable.
Okay.
Now, before we go on, let's not go on. Shoot. I didn't mean to erase it all. I'm going to write it on there again. Because there's something called L'Hopital. Oh, boy.
It's called what?
L'Hopital's rule.
Okay.
And what L'Hopital rule, it's spelled like hospital.
Okay.
Pronounced L'Hopital. Another thing you don't get until you get to chapter 8. But if you want to find the limit of 0 over 0, if you take the derivative of the numerator, the derivative of cosine is I will teach you this shortly, but the way you take the derivative of the numerator is you take the derivative of cosine, which is minus sine. The derivative of any number is 0, so that's the derivative of the top. The derivative of the bottom is that.
Okay.
Now I resubstitute, and I continue to get 0 over 0. So I do that process one more time. I take the derivative of the top, which is don't worry about memorizing this yet. We'll get to this. There's the derivative of the bottom. Resubstitute. What do I get? There's your answer right there.
Okay.
Okay. So just kind of keep that in the back of your mind, that there are ways of handling these difficult limit problems by taking the derivative of the top and the derivative of the bottom and resubstitute. Now,
yes, sir.
I know you don't even know what derivative is yet.
No, sir.
Well, here's what derivative means. First time in math that you run into x plus h instead of x minus h. That's the definition of first derivative.
That says, hold on, let me. Oh, wait a minute.
This is the slope of the tangent line, is what first derivative is going to give you.
So that says.
Let's let's do an example problem. Let's take an easy one. X squared. How do I take the derivative, the first derivative of x squared?
The first derivative of x squared.
Here's the methodology you want to use. It's not as hard as it looks. First of all, write what f of x is. Second of all, write what f of x plus h is. What is f of x plus h?
So x plus h squared?
You got it. That's all you do. Now, let's apply it to this problem.
All right.
I'm taking the limit of that as h goes to 0. So what do you get?
Hold on. So the equation on the top, it says f of x plus h minus f of x minus h. Is that what it says?
No, it's f of x plus h minus f of x.
Minus f of x, okay.
All divided by h as h goes to 0. Whenever you see that denominator going to 0, you know you got this a calculus problem. Because you can't divide by 0. The first rule of mathematics. So calculus all is based on that denominator going to 0.
Okay.
So somehow we have to manipulate this thing and see if we can get rid of that denominator going to 0. Well, expand the numerator.
So it's going to be x. Do you want me to just expand it or simplify it?
Simplify the whole numerator.
So we wouldn't even have the x squared term.
Correct. What you're going to end up with, every term you're going to end up with has an h in it. So what's the numerator?
2xh plus h squared over h. Well, yeah, just.
Now you see what rule you can use. Which technique are you going to use to solve that?
You're going to use the factor.
Correct. Factor that. What does it come down to?
2x plus h
Tell me what the limit of that is as h goes to 0.
2x.
That's the answer. That is the first derivative. If I said, what is the slope when x is equal to 3? What is the slope of the tangent line? Here's x squared, here's the function. And here's 3. What's the slope of this tangent line right there?
So is that 6?
In other words, the function that is the first derivative of x squared is 2x. So wherever x is, you can figure out what the slope of the tangent line is. So once again, calculus is about manipulating functions. Okay?
Okay.
I'm going to give you one more tough one, and then I'm going to introduce you to all the easy ways that they teach you. I've always been a huge proponent of teaching you the easy ways first, but you're smart enough to understand, your algebra is good enough to do these harder ones. So
okay.
Let's do it. In this case, f of x is 1 over x. So we want the first derivative of that. And the first derivative is this. This is the official definition of first derivative. They force you to do it when you first learn calculus, and then you never do any of them like this anymore. This is the last one we're ever going to do. So what's my first step?
Okay, so you have to find out what the function of x plus h is.
No, you want to find what f of x plus h. Okay, that's exactly what you said. What is it?
It is 1 over x plus h.
Okay, now...
So we'll plug that in.
This is where your algebra has to be good. Simplify the top.
So
that's why people hate calculus students hate this official definition of first derivative. You won't fully understand why until I give you all the easy ways to do it.
Okay, so would we just find a common denominator for the...
You got it?
All right.
Again,
so
always write it like this. Don't distribute the bottom.
Yes. All right, so that's...
denominator, right?
Yes.
Those are two numerators. What's the numerator end up being?
All right, so that's x minus x plus h. So that is going to be minus h over...
Very good. That you got the sign right.
Yes, sir. Over x times x plus h. Over h.
So keep simplifying.
Okay, so divided by h, that's going to be the same thing as multiplying by 1 over h. So that's going to be negative 1 over x times x plus h.
What is that limit as h goes to 0?
Negative 1 over x squared.
That's the answer. Okay? If you can do those two problems, you can do most any of them. They obviously do get harder. If you're looking at the limit of sine plus, or sine of x plus h minus sine of x, you're going to have to use the plus and minus identity for sine to solve it. But eventually you would determine what the derivative of sine is. Okay? All right, that's it with that official definition. You're going to run into problems that do require you to do that, but they'll look a little different. Okay, what I'm going to do now is teach you the power rule.
All right.
Power rule is extremely easy.
Okay.
You start by multiplying the thing by the exponent, and then you subtract 1 from the exponent. It's that simple. Remember when our function was x squared? Apply the power rule.
All right. So that's going to be 2x.
Much easier than the way we did it, right?
Yes, sir. The power rule, this also finds the first derivative?
Uh-huh.
Huh.
Let's do it on the harder one that we did. Now, before we do it, let's write that the way we want to write it. We want our x, if we're going to use the power rule, we want the x to be in the numerator. So this means first derivative, f prime of x. That's what that little tick hash mark means, is first derivative.
Okay.
Apply the power rule.
All right, so that's going to be -1 times x to the -2.
Which is?
To the -2 power, which is
Exactly what we got when we did it the hard way.
Yes, -1 over x squared.
Okay. I think you got the power rule down. Let me give you some functions. Here, let me not write so hard. What's y prime?
All right, so that's going to be 20x to the 4th.
Okay. Easy. If you have a polynomial,
okay,
like this, the derivative is the sum of the derivatives of each term as long as each term is being added or subtracted, not multiplied or divided. So tell me y prime.
all right, so that's going to be 15x squared plus 2x.
The derivative of a number is always 0.
The derivative of just a coefficient?
Of just a number.
Just a number.
No variable involved, yes.
No variable.
The derivative of all numbers is 0.
All right.
Okay. If I'm looking at this function and I'm graphing it, what's the slope of that function at x equal 1?
Okay. So that is that.
By the slope of the function, I mean the slope of the tangent line to the function, but that's also the slope of the function.
So that's just the 15x squared plus 2x.
In other words, that's the way you write it. What is the first derivative of the function evaluated at 1?
So, yeah.
Okay. In a nutshell, that's the power rule. Okay.
Okay.
Understand that? That's the general description of the power rule.
Yes, sir.
Okay. Next thing we're going to talk about are derivatives of trig functions.
All right.
Trig functions are huge in calculus. So let's talk about first derivatives of all of these trig functions. This is f of x. This is f prime of x.
All right.
Derivative of sine is cosine.
Okay. And are we going to go into that, or do I just need?
You could figure it out by going through that official definition. In other words, you'd have to take the limit of sine of x plus h minus sine of x, all divided by x as x goes to 0. And this is the one where you would apply the plus or minus identity to the sine of x plus h. And if you go through all of the algebra and trig, you'll find out that it's equal to the cosine x.
Yes, sir.
For now, just memorize it.
All right.
There's 3 of these that the only thing you can do is memorize them. That one is secant squared of x, a weird one, and tan, secant and again, you have to memorize these 3.
Those 3.
Those 3. Because the other 3 you can figure out. Okay? You familiar with what a cofunction means? What's the cofunction of sine?
Cofunction of sine, that is...
Stick a co in front of it.
Oh, that's right. It's cosecant.
No, just stick a co in front of it.
Oh, cosine.
Okay. What's the cofunction of cosine? Take a co out of the way.
Sine.
Right. What's the cofunction of tangent?
Yeah, okay.
Yes. Don't get these confused with reciprocal.
Okay.
The reciprocals are different. The reciprocal of sine is 1 over cosecant.
Okay.
Okay? So these are not reciprocals. These are cofunctions. And cofunctions is real simple. You either add a co to the front or you take it away. So the cofunction of tangent is cotangent. The cofunction of cotangent is tangent. Cofunction of secant is cosecant. Cofunction of cosecant is secant.
Okay.
So first thing I'm going to do is figure out what the cosine of x is. And these 3 all begin with negatives, and the answer is whatever the cofunction of the thing above it is.
Okay.
So what's the cofunction of cosine?
That's going to be sine.
So the first derivative of cosine of x is negative sine of x.
But the first derivative of sine.
Let me give you the other 2.
But the first derivative of the sine of x is just the positive cosine.
Yes.
Okay.
Okay. This one is a secondary one. It's going to start with a negative sign, and it's going to equal whatever the cofunction of what you see above it is.
So that's the negative tan of x.
No, what's above that negative sign?
That is the cosecant.
No, right. So that's what, in other words, I want you to use the cofunction of secant x squared, secant squared of x, which is cosecant squared of x. That is the first derivative of cotangent.
Okay.
And the third one, last one, going to begin with a negative sign, because these are all cofunctions. Notice that every one that begins with a negative sign is cosine, cotangent, cosecant.
Yes, sir.
What's that going to be? Under the same pattern.
Cosecant x, cotan x.
Very good. So you can see that you only have to memorize these 3, which is good because otherwise that's 6 things to memorize. It's much harder. In other words, memorize those basic 3, and then you can figure out all of the cofunctions.
Yes,
Cofunctions start with a negative sign, and they are merely the cofunction of whatever the first derivative of the thing above it is. Now, you do need to know all 6 of these.
All 6, that's right.
I'm just presenting it to you in a way that it's easier to memorize. And it's different than most books, because most books start you out with number 1 and 2, which is a bad way to start you out, because it makes it look like it's just the negative opposites. And that's not what's going on at all. Okay? The way you want to teach anybody this is this way: 1, 2, and 3, and then they can figure out 4, 5, and 6. This being 4, 5, and 6. 4, 5, and 6 all begin with a negative sign, and their answer is the cofunction of whatever the first derivative of the original function was.
Yes.
Okay? So, I don't know, you might want to take a snapshot of this. Do you have a calc book yet?
No, sir, not yet.
That's fine. I would take a snapshot of this if you don't have a calculus book, because you do need to refer back to this a lot.
Yes, sir. I'm going to get a picture of that right now.
I hope I wrote it legibly enough.
Yes, sir, it is. I got it.
Get it? Okay, cool.
All right.
All right. There's a few other functions that you have to memorize in terms of what its first derivative is.
Okay.
There's one. The only function in the universe whose derivative is the same as the original function. That is what's so magical about e. E to the x. That's what makes it so important in all those precalculus classes you were taking. Is because of this. There's only one other function that is that way, and that's that one right there. Notice that that is also the same, but it's irrelevant because that's not an important function. F of x equals 0.
Okay.
Okay? So we tend to ignore that, and e to the x is so special because its derivative is the same as what it is.
All right.
Okay? Just for purposes of why the derivative of a constant is 0, there's that function, right?
Yes, sir.
What's the slope of the tangent line?
Slope of the tangent line, that is...
Here's the function. I should have put it in dots. There it is. What's the slope of that line?
That is under...
It's 0.
Wait, that's 0. That's 0.
That's 0. That's why the first derivative of all numbers is 0. Because no matter what this number is, it could be 17, it's a horizontal line.
Okay.
And don't forget that first derivative means slope of the tangent line. The slope of that function, basically. You don't need to always remember it as slope of the tangent line, but if I've got a function that does something like this, well, the slope of the tangent line right there is 0. Slope of the tangent line right there is something else. Slope of the tangent line right there is something else. So when I talk about first derivative, I'm talking about the slope of the function that goes wherever I want to talk about it.
Yes, sir.
Hold on. Sonny, hold on. And you can kind of see why knowing if you go in reverse, what would I want to know about that function? I might want to know where that occurs, where that minimum occurs, right?
Yes, sir.
Well, what I can do is take the derivative of the function, set it equal to 0, because I know right there at that minimum point that slope of the tangent line is 0. And I can work backwards. That's one of the huge pluses of calculus, is that you can figure out minimums and maximums when you don't have any other way to figure it out.
Huh.
Also, the derivative is equal to 0 right there. So if I take the derivative of that function, set it equal to 0, I'm going to find two answers. One's right there and the other's right there. It's a beautiful thing. The fact that regardless of the function you're looking at, all functions usually look something like this, right?
That's right.
Well, I can tell a lot about that. What if I want to know where that point right there is on the x-axis? Or this point right here, or this point right there, or this point over here. Notice that those are the only 4 points where the slope of the tangent line is equal to 0.
That's right.
Okay. Well, let's take a function.
Okay.
So, if I'm going to take the derivative of this function, tell me what the derivative is.
Okay, so that's 3x squared minus 4x minus 15.
No, plus 5. Oh, the one thing I didn't show you.
Wait. Yeah, plus 5. I wrote that wrong. Plus 5. I wrote it wrong.
Right. If you use an exponent of 1 there, you get 5. In other words, 1 times 5 times x to the 0th power, which is 1. So you can use the power rule on that right there. But just know that whenever you have a coefficient in front of a x to the 1 value, the derivative is that coefficient. Okay?
Yes, sir.
So if I know that this is the derivative function, now set that equal to 0, and that's going to tell me all of these points. It's going to give me that point, that point, that point, and that point. Or in this case, it's going to give me 2 answers. I have a quadratic, right?
Yes, sir.
I know I plug it into the quadratic formula and I find 2 answers. That's because this graph does not have 3 humps in it. The graph of this cubic only has 2 humps. So I would expect to find 2 places where the slope of the tangent line was 0. And I would. If I graphed that thing properly, it's going to graph like this. When you have a cubic, only has 2 humps. These are called extrema, local extrema.
Extrema.
Extrema. EX, it's an important term in algebra or calculus. Okay. What a local maximum means, this is a local maximum. It's not an overall maximum because you can see that we have points way up here that are much higher.
Yes, sir.
But in some range, that is a local maximum. And the definition of a local maximum is if you have points to the left and the right that are lower than it. Down here, we have a local minimum because we have points to the left and to the right that are greater than that. Whenever you have a local maximum or minimum, you know the slope of the tangent line is 0.
Yes.
So the curve that I have drawn is much more realistic for that original function. I'm not sure that it looks like this, but most cubics have two local maximums in it, or a local maximum and a local minimum. If you have a quartic function, you're going to have 3 humps. If you have a 5th degree function, you're going to have 4 humps. Each one of those humps is going to have a spot on it where you have a 0 slope tangent line.
Okay.
So to figure out where they are, all I have to do is solve that.
Okay.
It's not easy to solve. You probably need to use the quadratic formula, but that would tell you where those 2 points are right there. It would tell you that point, and it would tell you that point. Remember, you're solving that quadratic to figure out what the values of x are going to be that make that whole thing equal to 0.
Yes, sir.
Okay. So that's kind of where we're going. It's 4:30, so this is a good place to stop. And next time, there are only 3 more rules to master derivatives. And that's the product.
Really?
We've done the power rule. There's also the product rule, the quotient rule, and the chain rule. And all of them are like the product rule. They're pretty straightforward, and you can memorize all of them. They're not as easy to memorize as the product rule, but between those 4 rules, you can differentiate any function. No matter how, it could be a 9th degree function. And between these 4 rules, you can differentiate it.
Wow.
Without doing any of that nonsense. I call it nonsense, but the official definition of first derivative, f of x plus h minus f of x, you don't ever have to use that again.
Yeah.
But the product rule and quotient rule are a little complicated, and the chain rule is a little bit more complicated. But trust me, not anywhere near as complicated as integral calculus will get. Differential calculus is actually quite easy in that it can be summed up with these 4 rules pretty much. And some of these concepts, certainly some of the word problems that we'll run into in differential calculus are going to be hard, but very doable using these 4 rules. Can't say that about integral calculus. Much harder. Okay, so stop there, and I will talk to you next Tuesday, and we'll pick up from there.
All right.
Okay.
See you then.
Okay.
Have a good day.
You too. Bye-bye.